Depreciation schedule continued. Having forecasted the individual capital expenditures from each asset classes, we can now project the depreciation balances. For each asset, the depreciation balance is forecasted in two steps. 1. Depreciation expense of the historical assets John Lewis currently holds as of 2009 ending. 2. Depreciation expense contribution due to incremental capital expenditures in 2010-2011 onwards. Depreciation policy assumed here is the straight line method, and we have also assumed useful life to be same as the useful life of the historical assets. Remember, land is a non-depreciable asset and hence will not depreciate land. Let us now look at the calculation of depreciation for building improvements. The useful life is 7 years. Step 1. Depreciation calculation of historical years. This is calculated by straight line depreciation of 100 million over 7 years is equal to $B $34 divided by $C $34 is equal to 14.3 million. Remember to put the dollar signs as we don't want these cells to move when we copy paste this cell for other years. Step 2. Depreciation calculation for the incremental building improvements from 2010 onwards. For this, we need to first link these capital expenditure numbers here. We can link this one by one. For 2010 is equal to E27. For 2011 is equal to F27. Please note, we cannot use a simple copy-paste. I'm sure Excel can provide us with a lot of tricks to ease our lives. Some analysts suggest using paste special transpose function for handling this situation. Let us see how paste special can be used. Select row 27 from 2010 till 2016 and then click Ctrl C. Now go to cell B38. Do a right click and choose Paste Special. The Paste Special window opens up. Under the Paste tab, we choose Values, and at the bottom of the table we checkmark Transpose. With this, our building improvement capital expenditure figures in a row and populated in a column. This is done by most analysts. However, think for a moment. Your capital expenditure figures are dependent on sales figures. Remember, 7% of sales is capital expenditure. Let us say at some later stage, if we update or change our sales figures assumptions, the capital expenditure figures would change correspondingly. However, if we use paste special, values, and transpose, the capital expenditure numbers used for depreciation calculation will not change. Hence, we need to have an upgraded formula for handling such situation. The professional analyst approach is to use transpose function using arrays. The formula is relatively simple. We simply type is equal to transpose E27 to K27. On pressing enter, we get hash value. We have not done anything wrong here. We are just trying to display an array of numbers in a single cell and therefore an error. For displaying the transposed array, we need to now select from cell B38 till B44 and we then press function key F2 for edit. Thereafter, simultaneously press Ctrl Shift and enter. you will now find that all the data is now transposed, and if you change any number, the linkages are appropriately updated. For calculation of depreciation, we also require useful life. In our case, we are assuming this to be equal to 7 years. However, this assumption can be modified to represent higher useful life of newer assets than older assets. In cell E38, we calculate the depreciation expense. That is equal to B38 divided by C38 is equal to 4.1 million. Likewise, the depreciation of 4.1 million is capable for other future years. For depreciation due to capital expenditure of 33.3 million in the year 2011, we will have incremental depreciation expense is equal to B39 divided by C39 is equal to 4.8 million. Please note that this will start from column F and not from column E. This is because the 33.3 million capital expenditure was done in the year of 2011 and there will be no contribution in 2010. Likewise, we need to complete the calculation of depreciation for capital expenditure done in 2012 onwards. As always, an analyst should use Excel references smartly. And we can modify this formula a bit using references to is equal to $B38 divided by $C38. This helps us to copy-paste the formula not only from left to right, but also from top to bottom with all the correct linkages, and definitely this will result in saving us a lot of time. This table is known as waterfall table. Please note these set of number now highlighted in yellow. In these cases, the assumption is that full depreciation to be charged in the first year of asset creation may not be realistic. Here, we are assuming that the capital expenditure assets were created on the first day of the financial year. However, we may not know the exact date of asset creation, and therefore it is strongly advised if we make use of a mid-year convention. This assumes that instead of charging a full depreciation here, we charge only the half depreciation. For this, we have to divide all the highlighted yellow numbers by 2. The total depreciation contribution because of building and improvements is not only this original 14.3 million, but also the addition of incremental depreciations from the waterfall table. For this, we write this generic formula is equal to E35 plus sum E38 to E44 is equal to E16.4 million. We apply the same formula for the depreciation expense of the future years. Machinery and equipment's depreciation. First and foremost is to link the original machinery number to cell B50 is equal to 700 million. The useful life given here is 9 years.